Okay, guys, we're going to balance redox equations in basic solution this time. This is going to be very similar to what we did last time in balancing the redox reaction in acidic solution. But in basic solution, there's just one small difference. Before we get into it, though, I wanted to emphasize the difference between acidic and basic. What is it that what ion makes things acidic, guys? H+. So when we're talking about acids, we're measuring the H+ concentration. What ion makes things basic? OH-, which is the hydroxide ion, right? So if you have more hydroxide in the solution, then it becomes more basic. Let's talk about it in terms of pH. You guys remember from last year the pH scale goes from what to what? From 0 to 14. What's right in the middle? 7. That's what water is, so it's neutral in terms of pH. But as you add more OH-, if you add more hydroxide, what happens to the pH? It goes up, right? The pH would go up. So 14, you'd have a lot of hydroxide in your solution. What happens if you add more H+ ion to the solution? The pH would go down. So closer to 0 is a very strong acid. Anyway, we're going to balance these in basic solutions today. So I wanted to go over the rules for balancing redox equations in basic solutions. I want you to notice something. Does rule number 1 change? Or is it the same as last time? It's the same as acidic solution. Write the half reactions. Step 2. Balance the atoms other than oxygen or hydrogen. Is it the same? Yeah, it's the same. Step 3. Balance the oxygens by adding H2O. Exactly the same. Number 4. Balance the hydrogens by adding H+. Again, same. Number 5. Balance the charges by adding electrons. We did that last time. Number 6. Make the number of electrons equal for each half reaction and then add the half reactions together. So, guys, good news. From 1 to 6, it's the same. The only difference when we do it in basic solution is step 7. So let's pay attention to this part. It says to add OH to any H+ to form water. Then adjust the water as needed. Okay, I want you to add this to your notes, to your rule sheet there. It says add OH to any H+. You're going to add OH to both sides. Please make that note. You're going to add the hydroxide to both sides. So we'll talk about that in a moment. But let me explain what adding OH to any H+ means. So if you end and there's 2 H+. Let's say there's 2 H+ on the left side. Okay, I don't know what's on the right. How would you complete step 7? Good. You're going to add OHs, okay? But if you add it to the left, what do you got to do? To the right. Same, it's just like a math equation, guys. If you add something to the left, we're going to add it to the right. Now, if there's 2 H+ here, how many hydroxides will I have to add in order to form water? I better have 2 of them, right? How many waters will that make? That makes 2 H2Os. See, whatever the hydrogen ion is here, whatever your coefficient is here, you're going to add that same coefficient with hydroxides. And then you're going to add them together to form water. So if you have 2 hydroxides and 2 H+, that's going to make 2 waters. Okay. But since you added 2 hydroxides, you've got to add 2 hydroxides to the other side. Whatever you add to the left, you've got to add to the right. That's the point I'm going to emphasize in this lesson today. All right, let's go through a practice problem. It will make more sense. Okay, so practice problem number 14. We're going to balance this redox equation in basic solution. So, first step, we need the oxidation numbers. What's the oxidation number of I-? It's -1. Whatever its charge is, it's going to be its oxidation number. Oxygen's always a -2, but I've got 4 of them. So what is it total? -8. This thing has a -1 charge, so it's got to sum to a -1. What does the manganese have to be? +7. Good job. Iodine, just by itself, doesn't have a charge. What's its oxidation number? 0. Yeah, free elements are 0. Oxygen's always -2. I've got 2 of them, though. -4. So what does the manganese have to be? +4. There's only one of them, so it's got to be +4. I'm going to erase the totals from the bottom so it doesn't confuse us. Okay, which one, guys, is being oxidized? Yeah, the iodine is going from -1 to 0. Isn't that going up still? So that one's oxidized. Which one is being reduced? The manganese. Yeah, it's going from +7 to +4, so that one's reduced. Step 1 through 6 is the same. So let's just use our rule sheet. If you're watching the video, please have your rules out. And we're going to go through it step by step here. So that step 1 is to write the half reactions. So I've got I-, and that's going to I2 for one half reaction. The other half reaction will be MnO4-. Please remember to bring down the charges, and that goes to MnO2. Okay, so step 1 is done. Now let's go to step 2. Balance the atoms other than the oxygens or hydrogens. Iodines, are they balanced? No. How do I balance it? Yeah, I've got to have a 2 right there to balance that. Manganese, are they balanced? Yeah. Okay, so step 2 is done. Step 3, balance the oxygens by adding water. Well, I don't have any oxygens in this oxidation half reaction, so let's move on. Oxygens here, I've got 4. On the right side, I've got 2. Which side needs water and how many? 2 on the right side. Good, I agree. So 2 waters here will give me 2. 2 plus 2 oxygens is 4, which balances that 4 oxygens. Okay, step 4. Balance the hydrogens by adding H+. Again, we have no hydrogens here, so we're done. Come down here. I've got 4 hydrogens right here. How many H pluses and on which side? Good. 4 H pluses on the left side. Okay, step 5. Balance the charges by adding electrons. I've got a -2 charge right here. So a -2, I'm going to make note of that. And on this side, I've got 0. Which side needs electrons and how many? The right side. Yeah, whatever side is more positive, I know it's 0, but it's still more positive than the -2. So I need 2 electrons here to balance the charges. Let's go to the bottom one. I've got +4 right here and a -1. What does that add up to? +3, so I'm going to make note of that. And the other side, I have what? 0. Which side needs electrons and how many? The left needs 3. Because now that balances us. This side is 0 and this side is now 0. All right, now that was step 5. Let's go to step 6. It says to make the number of electrons equal for each half reaction. Well, the top one has 2 electrons, the bottom one has 3 electrons. How are we going to make them equal, guys? What's the lowest number that 3 and 2 will go into? 6. So I need to times this reaction with a number that will make us have 6 electrons. What number is that? 3. What will I times the bottom reaction by? 2, because that's how we're going to get to 6 electrons. So find your least common multiple and try to get to that with your electrons. Okay, now we distribute it through, and I'm going to write the equations down below. So I've got 6 I minuses. That's going to 3 I2s plus 6 electrons. Okay, I'm going to distribute this bottom one through now. 6 electrons plus 8 H pluses plus 2 MnO4 minuses And then if we distribute the 2 over to here, so we've got 2 MnO2s plus, again, 4 waters. Okay? Now let's add them together because step 6 says once we've got them equal, then we add the half reactions together. When you get to this point, it's a good place to check yourself. The electron should do what, guys? Shouldn't they cancel out? And they did in that case. 6 electrons on the left cancel out 6 electrons on the right. Let's cancel out any other like terms. What else can I cancel out here? There's nothing else I can cancel out, is there? Okay, so I'm going to write, let's add these two equations together, and I'm going to write what they equal down below here. So I've got 6 I minuses on the left, and let's go down here on the left. I've got 8 H pluses plus 2 MnO4s minuses, bring down the charge as well. And then I've got nothing else on the left, so draw your arrow. On the right, now I've got 3 I2s plus 2 MnO2s plus 4 waters. Okay, everything has been the same in this basic solution as it was in the acidic one, right? Up to this point. Now here's where it's different. In a basic pH, we're going to add OH to any H pluses to form water. If I've got 8 H pluses, how many hydroxides am I going to add? 8. So I'm going to put that right here, plus 8 OH minuses. Okay, now if I add 8 to the left side, what have I got to remember to do? Yeah, I've got to add 8 over here. It's just like a math equation. If you add it to the left side, you've got to add it to the right side. Okay, now it says to form water. Well, how many waters will this and this form? That's going to form 8 H2Os, right? So I'm going to, and if I've got 8 positives and 8 negatives, my charge is now 0 for water. So I'm going to erase all of this because it made 8 waters. Okay, but then on step 7, it also says to adjust the water as needed. If I've got 8 waters on the left, how many did I have on the right? 4. Are all 4 of these going to be canceled out? Yeah, so those 4 are gone. How many's left over here? 4. Okay. And that's it. Now let's write the equation as it should be. I'm going to write the answer over here. So I've got 4 waters plus 6 I minuses plus 2 MnO4 minuses, and that goes to 3 I2s plus 2 MnO2s plus 8 hydroxides. Remember, hydroxide has a -1 charge. Okay, I believe that's what the answer is. How could I check and make sure? Well, let's count. How many hydrogens here, guys? 8. How many hydrogens on this side? 8. How many oxygens? 4 plus 8 is 12. And I've got 4 oxygens here plus 8 more here is 12. Iodines, I've got 6. On the right side, I've got 6. Manganese, I got 2 and 2. Now let's balance the charges. -6 and a -2 is what? -8. Over on the right side, I've got -8. Does it balance? Yeah, so that's a good way of determining whether you did it right or wrong. And so, yes, we got the answer right. So, a lot of work, I know, but it's almost exactly the same. Through step 6, it is the same. You just got one more step and in basic solutions, and I think it's pretty easy. Okay, I've got a couple more practice problems. I would like you guys to try this one on your own. Okay, again, it's in basic solution, You guys try it. See if you can get it right. If you're watching the video, please hit pause, try it. Once you have an answer, hit play and see if you got it right. Okay, guys, let's see how you did. I'm going to go through and assign the oxidation numbers now. Oxygen is always -2, but there's 4 of them, so that's -8. This thing has got a sum to a -2. So in order for that to make sense, this chromium has to be +6. There's only one of them, so it is +6. Iron is +2. Well, its oxidation number equals the charge for monoatomic ions. Cr +3, so again it's +3. And iron here is +3, so again the oxidation number is +3. Let me go through and erase all these bottom numbers here so don't get confused. Okay, now you got to decide which one is being oxidized, which one is going up in its oxidation number. And it looks like to me the iron is going up, so that one's being oxidized. The chromium is going down in its oxidation number. It's going from +6 to +3, so it's going down, so that one's being reduced. Okay. I'm going to write the half reactions now. So we got Fe +2 goes to Fe +3. The other half reaction will be CrO4 -2, and that one is going to Cr +3. Okay, so that's step 1, is to write the half reactions. Now let's go to step 2. Balance the atoms other than the oxygens and hydrogens. Well, my irons here are balanced. I got 1 and 1. My chromiums are balanced. I've got 1 and 1. So that step's done. Let's go to step 3. Balance the oxygens by adding water. Well, I don't have any oxygens here, so we're balanced in terms of oxygens. Let's go down here. I've got 4 oxygens. The right side has 0, so I need to balance it, I need to get more oxygens. I'm going to do that by adding water. But if I've got 4 oxygens, I'm going to need 4 waters, because that will get me to 4 oxygens. Step 4, balance the hydrogens by adding H+. Again, I don't have hydrogens up here, so we're done. On the bottom, now I've got 8 hydrogens on the right side. I don't have any so far on the left, so I need to add hydrogens to the left side. I'm going to have to add 8 of them. 8 H+'s. Balance them. Step 5, balance the charges by adding electrons. The charge here is +2. The charge on the right side is +3. You're always going to add electrons to the side that's more positive. To balance the charges here, I'm going to have to add 1 electron. How come? Well, +3 minus 1 is +2, which is what this side is. Okay, let's figure out the charges for this one. I've got 8 positives here. I've got 2 negatives. So that is a +6. I'm going to make that note, +6 on the left side. So far on the right, I've got +3. Okay. Which side is more positive? Well, the left side's more positive. I've got to add electrons to that side. How many electrons should I add to balance it to +3? And the answer is 3 electrons. Okay. So step 5 is done. Step 6 is to make the number of electrons equal for each half reaction. I've got 3 down here, and I've got only 1 up here. So how am I going to make them equal? Yeah, if I can get to 3 electrons, which I can by timesing this top equation by 3, that will make it equal. So if I distribute this through, I'm going to write the answer down here so there's more room. So I'm going to have 3 Fe +2s goes to 3 Fe +3s plus, now we have 3 electrons. Okay? I'm going to put a line through that one because I've already distributed it. I don't want it to confuse us anymore. Okay, once the electrons are equal for each half reaction, which they now are, it says to then add the half reactions together. So we're going to add them together here. Now when you get to this point, your electrons should always cancel out. 3 electrons on the left cancels out 3 electrons on the right. Now we should also look for other terms that can be canceled out. In this case, is there any that can be canceled out, guys? Nope. So then let's just add the half reactions together. Again, what that means is keep everything that's on the left on the left. So I've got 8 H pluses plus CrO4 minus 2 charge plus these 3 irons that have a plus 2 charge. And that's everything that's on the left because we canceled out the electrons. Okay, now let's draw our arrow. Now let's put everything on the right. So Cr plus 3 plus 4 waters plus these 3 irons that are a plus 3 charge. Okay? Now we've added them together. Now this is where balancing them in basic solution is a little different because it's got one more step. It says on step 7, add hydroxide to any H plus to form water. Where's our H plus at, guys? It's right here. So I'm going to add the hydroxides right here. How many hydroxides will I need in order to make water?
8.
I need 8 of them. If I add these two together right now, how many waters will that make? Well, let's just see. How many hydrogens? 8 and 8 is 16. So when I have water, how can I get to 16? Well, I need 8. So it's really easy, guys. Whatever your coefficient is going to be the number of waters you make. So I just made 8 waters. But guess what? If you add 8 hydroxides to the left side, what do you always need to remember to do? Put it on the right. I promise you're probably going to make a mistake not doing that. So if yours doesn't add up in the end, make sure you go back and say, well, if I added 8 hydroxides to the left, how many hydroxides do I need on the right? I need 8 of them. It's just like a math equation. Whatever you do to one side, you've got to do to the other side. Okay, and then on step 7, it also says to adjust the water. Because we just made water right here, can I adjust the water? What that means is these 4 waters here are going to cancel out these waters. How many waters am I going to be left with? 4. Because we had 4 over here, 4 of them cancel out, 4 of them on this side. Now we're done. Okay, now let's rewrite it. Okay, I'm not going to write the hydroxide and hydrogen ion here. I'm going to add the water. So we got 4 waters plus the CrO4 minus 2 plus the 3 irons have a plus 2 charge. And that goes to Cr plus 3 plus 3 Fe plus 3s plus 8 hydroxides. Now I believe that is our answer, but how do I make sure? Well, let's balance it. How many hydrogens? 8. How many hydrogens? 8. How many oxygens? 4 plus 4 is what, guys? 8. And how many oxygens over here? 8. How many chromiums? 1 and 1. How many irons? 3 and 3. So in terms of the number of atoms, we're balanced. But also you got to make sure you balance the charges. What's the total charge on the left side? Looks like we have a minus 2. And what's 3 times plus 2? Not plus 6. Minus 2 is what?
Plus 4.
Plus 4. I'm going to make note of that. We're plus 4 on this side. That means we better be plus 4 on the other side. We're plus 3 right here. What is this? 3 times plus 3?
Plus 9.
Plus 9. Plus 3 more is what?
12.
12. So we're plus 12. And then we're minus 8. What's plus 12 minus 8?
4.
Isn't that plus 4? Which is what we were. So that's definitely right. This is our answer. How come, guys, let me emphasize this. How come we're in basic solution here? Where does that come into play? With these 8 hydroxides, isn't that making it basic? Yeah. Okay. So that's practice problem number 15. Hopefully you were able to follow along with that one. I've got one more for you to try. Practice problem 16, okay? Try it on your own. Again, go through those steps in order, and I promise you will get to the right answer in the end. Okay, if you're watching the video, please hit pause. Try it on your own. Hit play once you got it done. Okay, guys, let's see how you did. I'm going to go through this one pretty quickly because it's our last one. You should know it by now. Oxygen's -2. We've got 4 of them, so that's -8. It looks like it sums to a -1. So the manganese has got to be +7. Bromine, it's a -1 charge. That means its oxidation number is -1. Oxygen's always a -2. I've got 2 of them. So that's -4. It sums to 0 because it doesn't have a charge. So that manganese has got to be +4. Oxygen's always a -2. I've got 3 of them, so that's -6. Looks like this one sums to a -1. So the bromine here has to be +5. Okay, so that's assigning the oxidation numbers. That should be second nature to us by now. So let's go to the steps. It says on step 1, write the half reactions. Well, which one is being oxidized? Which one's going up? The bromine here. Okay, so I'm going to put ox by this one. Which one is being reduced? Manganese. Guys, manganese is usually being oxidized or reduced, so that's just one that you should always look at first. That one's being reduced. It's going from +7 to +4. So step 1 is write the half reaction. Let's do that. So Br minus is going to BrO3 minus. Always remember to bring down the charges. That's where you're going to make an error. The other half reaction is MnO4 minus going to MnO2. Okay, now I'm just going to go through these rules step by step. Rule number 2 says balance the atoms other than oxygen or hydrogen. My bromines here are balanced. My manganese are balanced. So let's go to step 3. Balance the oxygens by adding water. I've got 3 oxygens on the right. That means I need some waters over here. How many waters? The answer is 3 because that gets me to 3 oxygens and 3 oxygens. Okay, my oxygens down here, I've got 4 and 2. So this side needs more. So I'm going to add more waters. How many more? 2 more waters because that gets me to 2, and 2 is 4, and 4 oxygens right there. Okay, step 4, balance the hydrogens by adding H+. Well, I've got 6 hydrogens on the left, so to balance that, I'm going to have 6 H pluses on the right. For this half reaction, I've got 4 hydrogens on the right. That means I'm going to have to put 4 hydrogens, 4 H pluses, on the left to balance it. Step 5, balance the charges by adding electrons. Well, water doesn't have a charge, but bromine is a -1. So I've got a -1 on the left side. So far I've got -1 plus 6. That's +5. So guys, how do I balance that? Always add electrons to the side that's more positive. How many electrons will I need? Yeah, good, Aiden. So I'm going to have to put +6 electrons on this side. If I only added 5, that would get me to 0. I need to add 6 to get me to a -1. So that balances it. Good job. Okay, let's look at the bottom one. I'm at +4 right now, and then a -1. So that's plus what? +3. And then on this side, I'm at 0. So how many electrons? Always add it to the side that's more positive, so we're going to add 3 electrons to the left side. Okay. All right, step 5 is done. Let's go to step 6. Make the number of electrons equal for each half reaction. Well, this one has 3, and this half reaction had 6. How am I going to make them equal? Do I have to do anything to the top reaction? No, the lowest number that 3 and 6 will go into is 6. So let's keep the top one as is and times the bottom one by 2. That gets me to 6 electrons. Let's distribute it through now. 2 times 4 is 8 hydrogens. Plus 1 charge here. And then we've got 2 MnO4s. And 2, negative. Don't forget the charges, I almost did there. Okay, and then we're going to have 2 MnO2s plus 4 waters. Okay, now that I have distributed that through, I like to draw a line through it so it doesn't confuse us anymore. Okay, then it says on step 6, once you make the electrons equal, we're going to add the half reactions. So let's add these 2 reactions together. Now this is where you cancel like terms. If you got 6 electrons on the left and 6 on the right, don't they cancel out? Let's look for anything else that will cancel. Usually waters. So I've got 3 waters on the left, 4 on the right. So all 3 of these are gone now. And how many is left over here? Just 1. So I'm going to make a note of that, just 1 water. Can I cancel out H pluses? I've got 6 on the right and 8 on the left. Aren't all 6 of these gone? And how many is left over here? 2. Okay. So now let's write, I don't think anything else can be canceled out, so let's write what we have. Everything on the left, so let's keep Br minus. And let's add everything else on the left, which I had 2 H pluses plus 2 MnO4 minuses. That's everything on the left. So let's draw our arrow. We have BrO3 with a -1 charge plus 2 MnO2s plus H2O. Okay. Let's stop right here. And now this is where balancing them in basic solution is a little bit different. So let's go to step 7. Aiden, it says add hydroxide to any H pluses. If I've got 2 H pluses, how many hydroxides am I going to have to add? 2. Good job. So we're going to put 2 OH minuses. But if I add 2 to the left, Aiden, what do I have to remember to do? Add 2 to the other side. Good job. So plus 2 OH minuses on the right. Don't forget to do that. And it says add the hydroxides to the H plus to form water. How many waters, Aiden, did I now form there? 2 waters. So what I like to do is just cross out the 2 hydrogens and cross out the 2 hydroxides, and we've made 2 waters. Now the other part of step 7 says to adjust the water as needed. If I now have 2 waters on the left, and I had 1 water on the right, what happens? How do I adjust it? Isn't this one going to be canceled out? And how many is left on the left side? Isn't it just 1? Okay. So now I've adjusted the waters. Now let's write the answer. Okay, let's write what's left. So we've got water right here, plus a Br minus plus 2 MnO4 minuses, and that's going to go to BrO3 minus plus 2 MnO2s plus 2 hydroxides. Okay, now that's what I believe the answer is. But how can we make sure that this answer is right? Let's balance the atoms. How many hydrogens here? 2. How many hydrogens on this side? 2. How many oxygens? What's 1 plus, and 2 times 4 is 8, so that's 9. So I got 3 here. What's 3 plus 4? 7 plus 2 more? 9. So 9 oxygens on both sides. Bromines, I got 1 and 1. Manganese, I got 2 and 2. And we already balanced the oxygen. So we're good in terms of the numbers of atoms. Let's balance the charges. I've got a -1 and a -2. So what is that total? -3 on the left. I've got a -1 and a -2. So that's a -3 on the right. Okay, that's the answer for this problem. Okay, so hopefully you got that as your answer. Guys, these are very similar to the ones we've been doing. So there's just one step at the end. I think we've got it now. To give you more practice with this, I've got a balancing redox reactions in basic solutions worksheet. So go to your student workbook and let's do that worksheet now. Again, it's balancing redox reactions in basic solutions worksheet. And hopefully this video helped.